Welcome everyone, I'm J Wildberger, and today we are going to use open numbers to start to reconfigure addition for primary school students. So an exciting new way of thinking about teaching young people how to add, okay? Absolutely fundamental technology in mathematics. Now, along the way, we're going to introduce something we call cascading. So that'll be kind of a pleasant feature of things. Okay, so let's start with reviewing the basic addition skill, okay, which is really fundamental for everything that we do in arithmetic, which is to be able to add a series of numbers, each of them between 0 and 9. So just single digits, one after the other. For example, 5 plus 8 plus 2 plus 9 plus 3 plus 7 plus 7 plus 1. We want to sum that up. Now, I want you to teach your young people to do this from left to right in a systematic way. No shortcuts, okay? No clever little tricks. Very crucial that they do not rely on any tricks. It's just one after the other, and they have to step up. Okay, so they have to know the addition table, and they have to understand the idea of wrapping around 10 or 20 or 30 or whatever it is. So, for example, this is what they should be saying to themselves, perhaps mentally. Okay, starting on the left. 5 plus 8 is 13. Plus 2 is 15. Plus 9 is 24. Plus 3 is 27. Plus 7 is 34, plus 7 is 41, plus 1 is 42. Okay, great. Now, what we want to do is we want to use this as the foundational skill to extend arithmetic to more complicated sums. And along the way, we're going to be using open numbers. So this is a different way of proceeding than you are taught currently. So let us illustrate what's going on, because a really good way of learning new technology is to watch somebody else do some illustrative examples. It's one thing to have things explained, and that's well and good, but it's perhaps even more important to actually see it in action, because explanations often can be interpreted in a number of different ways. So actually you are now in the same kind of position as a lot of young people are when they're learning. Okay? It's like you're learning arithmetic in a new way just here. Okay? And so you have to pay attention and you have to try to absorb what's going on. So it's maybe good practice to see things from a student's point of view. Okay? I'm trying to teach you a new way of doing arithmetic, and you want to learn this. Okay, so I'm going to illustrate it by looking at this rather imposing sum. 1,214 plus 378 plus 196 plus 7,551. And our approach is roughly to think about these numbers perhaps as money. So for example, 7,551, in terms of money, this represents one $1 bill, 5 $10 bills, 5 $100 bills, and 7 $1,000 bills. So each of these is a little portion of money, and we want to add them all up. Okay, so let's start from the left and work this way here. And we're going to start with the ones. Okay, the ones, there's 4 of them here, there's 8 of them here, 6 of them here, and 1 of them here. So we're going to add up all the ones. So 4 plus 8 is 12, plus 6 is 18, plus 1 is 19. Okay, and I'll put the 19 over on the right-hand edge because that's representing the total number of ones in the sum. Now we move to tens. There's 1 of them there, 7 there, 9 there, and 5 there. So we have to add up those particular ones. 1 plus 7 is 8. Plus 9 is 17, plus 5 is 22. So there are 22 tens in the sum. Now hundreds. 2 plus 3 is 5, plus 1 is 6, plus 5 is 11, comma, that's the number of hundreds in the total. And finally, the thousands, 1,000 here, no thousands here, no thousands here, 7,000 here, so 1 plus 7 is 8. There are 8,000 altogether. So if this was actual money and we actually put them all together, we'd see that there'd be 19 $1 bills, 22 $10 bills, 11 $100 bills, and 8 $1,000 bills. Okay, now we are going to rewrite this open number in an equivalent but perhaps simpler fashion by moving towards a closed number or a Hindu Arabic number where there's at most 9 of everything. Okay, so we'll start with the ones. Right now there's 19 ones. We're going to peel off 9 of them, and the other 10 of them are going to be joining the 10s over here. So how many 10s are there over here? There's 22 of them. But actually it's only this 2 that we're going to be concerned with at this stage. 2 10s here, plus that 1 10 from the previous one, 2 plus 1. So there's 3 10s. Well, actually there's another 20 10s. We haven't forgotten about that, but now that'll be included in the hundreds. So if we go to the hundreds, here there's 11 hundreds, but we're only going to look at this rightmost one, the 1. Okay, so there's 100 here, and that's going to combine with the 200s here. So these two go together to give us 300s. Right, so please think about that. So this 1 here is 1 of 11 hundreds. This 2 is really 20 of 22 10s. But 20 10s is the same as 200. So this 2 and this 1 are sort of really at the same level. So altogether there's 3 of those. So 3 hundreds. And finally, how many thousands are there? Well, there's 8 thousands here. But there's also an extra 1,000 here because of this, it's 11 here. It's really 10 hundreds plus 100. We've already talked about the 100. The 10 hundreds gives us another 1,000 for a total of 9. Okay, that was a little bit tricky, right? Because we have to sort of combine these judiciously. So the 9 here is there. Then we combine these two to give us 3. We combined these two also, in fact, to give us 3. And then we combine these two to give us 9. Now this is another open number then, which is equivalent to this one. But actually, it has the pleasant property that now all the entries or the digits are less than or equal to 9. So it's actually a Hindu Arabic number in the usual form. We can just write 9339. And there is a closed form for the original sum. Okay, so we have done the sum, basically relying on only this basic skill, keeping the ones, tens, hundreds, and so on separate until at the end we convert some to others to combine to give a closed number form. But the intermediate steps have involved these open numbers. So what are the advantages of using this open number approach to addition? So there are some very prominent advantages. One of them is that it matches more naturally with what we do with money. When we're working with money, we're not under any legal obligation to convert 10 $1 bills into a $10 bill whenever we have such. Okay? So there's more flexibility in the money kind of framework, and also with the open number system, it's the same. We have this flexibility because we're not constrained to always insist that there's at most 9 of any unit. Everything is on the page. So we end up writing things down kind of more concretely. When we do addition in the usual fashion, there's often these carries that end up kind of, as little footnotes or appendices up on the top in smaller type. And they end up often being a little bit confused. Often there's quite a lot of them, and it's not so clear looking at the computation at the end what the meanings of these various little footnotes or appendices are. So in other words, it's harder to recover very simply what the actual person who was solving the problem was doing. Therefore, it's harder to check if they made a mistake, where exactly did the mistake appear. So with this approach, we are more inclined to write everything down, so we are able to check more easily a computation. There's also a certain amount of flexibility that this method gives us, that actually we can work either from right to left, in other words, the way I've just shown you, starting with the ones and then the tens and the hundreds and so on. Or, in fact, we could also work from left to right, starting with the highest units first. There's some advantages to doing that. So, for example, if we were just looking to approximately add something, we would want to start from the left with the higher units because, practically speaking, they're more important. So with this open number approach, it doesn't matter which way we work. Okay, so that's an important flexibility. And also it'll turn out that this whole way of thinking prepares us for a more efficient multiplication procedure. Multiplication is definitely more complicated than addition. And so once we have this under our belt, we'll be able to see how to do multiplication in a much more natural and simple way also. Okay, so let's try to unpack the procedure by going back to some simpler examples, and let me show you the various steps that we're going to be using to approach addition. So we'll start with some simple additions, and we're going to actually put them in columns, okay? That'll help us organize the ones and the tens a little bit more easily. Okay, so the column format is often preferable, especially for larger sums. Once you start having a whole string of numbers, it's much easier if you put them in a column. Okay, so suppose we have to add 27 plus 35. Okay, so we're thinking about ones in this column and tens in this column. And when we're adding them from this point of view, we're just figuring out how many of each there are. So 7 plus 5. That's 12. We put a 12 there, okay? And ordinarily you would put a 2 there, and then the 1 would end up somewhere up on top here floating around. We're not going to do that. We're going to write down the 12 very clearly so it's completely visible, okay? And we're going to put a comma there to separate the ones total from the tens total, which is now coming up. So the tens total is 2 plus 3, independent of what we've achieved in the ones summation. 2 plus 3 is 5. So we put a 5 there. Now, this 12 could be converted into a standard closed number. So we could maybe do that, all right? So what would that be equivalent to? So the 12 can be thought of as 2 plus 10. So this 1 here is really a 10, effectively. So it can be grouped with this number of tens, 5 tens over here. So 5 plus 1 would be 6 tens. So altogether, this thing is actually 62. Okay, so that's using both steps. First to get a total, which is an open number, and then converting that total into a final closed form Hindu-Arabic number. That would be the traditional answer. Okay, let's have a look at this one. Here we have 3 numbers, 94 plus 78 plus 31. We do the ones separately from the tens. The ones is 4 plus 8 plus 1. Typically we like to read down. 4 plus 8 is 12, plus 1 is 13. So we write down 13. That's how many ones there are altogether. Okay? So somebody later on coming around, checking our work, can check and see what the totals are, and maybe we've made a mistake, and they can identify exactly where the mistake is. Okay, now we're going to put a comma here, and now we're going to add up the tens. Start at the top. 9 plus 7 is 16, plus 3 is 19. So there are 19 tens. So that's an answer as an open number. Okay, but we want a equivalent Hindu-Arabic number, so how can we convert this? So we convert it like this. The 3 stays, that's how many ones there are going to be. How many tens are there altogether? Well, the 1 and the 9 tell us how many tens there are. There's going to be 10 tens. So actually, it probably makes sense for us to put 10 tens there. And how many hundreds are there? Well, there's 100, because here we have 19 tens. And the 10 out of that 19 is really like 100. So we could separate that out like this. So this is an equivalent form for this one, but it's simpler in that it's closer to being a Hindu Arabic number. Let's go one more down here. Okay, so 3, that's the number of ones. How many tens are there? We can say there are 0 tens because we can move that 1 into 100. Okay, that's 203 then. So yes, there are a few steps because the process of converting our open number to a final closed number may involve a number of steps. Let's have a look at this example. 248 plus 409. 8 plus 9 is 17, comma. 4 plus 0 is 4, comma. 2 plus 4 is 6. Okay, great. What's that become? Well, number of ones is 7. Number of tens, there's 4 here and 1 there for a total of 5. And number of hundreds is just 6, so it's 657. All right, so these are 3 relatively simple examples of how we add using this open number approach. Okay, so let's have a look at the same procedure but with some larger sums. Let's consider 49 plus 27 plus 30 plus 72 plus 61 plus 48. This is conveniently in a column format also. Okay, so let's start with the ones. 9 plus 7 is 16, plus 0 is 16, plus 2 is 18, plus 1 is 19, plus 8 is 27. So we write down 27. That's the number of ones in total. Now we move to the tens column. 4 plus 2 is 6, plus 3 is 9, plus 7 is 16, plus 6 is 22, plus 4 is 26. So we get 26, comma 27. Now if we wanted to convert that into a closed number, in other words a Hindu Arabic number, we could start on the right with the ones. Altogether there is going to be 7 ones. How many tens are there? Well, there's 6 tens from this 6 in the tens position. But there's also this 2 here that's really acting as a 10 because this 2 represents 20 ones, which is the same as 2 tens. So altogether it's 6 plus 2 makes 8 tens. And how many hundreds? Well, this 2 here is in the second position in the tens column. So we're still in the tens position here, but it's 20 tens, which is the same as 2 hundreds. So we get 287 altogether. Here is another example, but now in a row format. Okay, we can still do it. So let's compute this. And just to show you the flexibility that we have, let's calculate the corresponding open number here from the left to the right. So we'll start with the biggest units now, the hundreds. So there's some hundreds here and here. These 3 don't have any hundreds. So how many hundreds are there altogether? There's 1 plus 5, so that's 6 hundreds. So we start with a 6 on the left and then make a comma. Now what about the tens? There's 1 10 here, plus 8, that's 9, plus 2 is 11, plus 7 is 18, plus 4 is 22. So there's 22 tens altogether. And finally, the ones, there's 8 plus 9, that's 17, plus 4 is 21, plus 3 is 24, plus 6 is 30. So there's the open number that represents this sum. Now, if we wanted to convert it to a closed form or closed number, we start with the ones. There will be 0 ones altogether. How many tens? Well, there's 2 tens here, plus the 3 tens represented by that 3. That's a total of 5. And then hundreds. Well, there's 6 hundreds here and 2 hundreds here. That 2 represents 2 hundreds because it's really representing 20 tens, which is the same as 2 hundreds. So we get 850 for the total. So we see that there is some flexibility with this system. We are ending up with a number in closed form, but along the way we use these intermediate objects which are open numbers, which have a greater flexibility and actually somehow more accuracy, more honestly reflects what exactly we're doing. We're adding up ones, we're adding up tens, we're adding up hundreds and so on, and we're just writing down the results of each one of those. So to summarize, there are 2 steps to adding a list of natural numbers. The first step A is to add up the totals for each unit. Okay, typically starting at the right with the smallest unit, the ones, and then the tens and the hundreds and so on. And we make all those totals, keep them separate with commas to create an open number. That's a kind of an answer, okay, but it's an answer as an open number. Then the second step is to convert the open number that we've just got to a natural number, or closed number, by cascading. Okay, so this is this process of looking at all these constituents of the open number and figuring out, well, how many hundreds are there altogether out of here? So that involves looking successively at certain components of previous ones if we're sort of moving from the right to the left. And that process is called cascading. And so that involves a bit more explanation to show you what's really going on there, to make this conversion smoothly to an open number to a closed number, or Hindu-Arabic natural number. All right, so what do I mean by cascading? It's actually quite a physical process involving placing the digits that appear in the open number successively down sort of a staircase fashion to facilitate the adding up or the determination of the total numbers in each of the columns. So we're going to align the digits of an open number sequentially in columns of 1, 10, 100, etc. from the right, and then total each column. Let me illustrate what I mean by that by going back to the 2 examples that we've just done and sort of peeling open in a little bit more detail how the conversion works. So our first one, we had an open number of 26, 27, and we want to convert that. Okay, so one way of proceeding is to place these digits in an array. Okay, so 27 is there, and then the 26 is in the line below it, so that the rightmost aspect is offset by 1. So it's kind of a staircase going down here like this. Maybe we could do it like that. All right. So why are we doing that? Because the 27 is 7 ones and 2 tens. So here is the ones column. Here is the tens column. Here is the hundreds column. Okay. So this 27 here is representing the 27 ones, which still amount to 7 $1 bills and 2 $10 bills. The 26 is 26 tens. Okay, there's 26 tens, and that's represented here. The 6 is in the tens column, and the 2 is in the hundreds column. Because 26 tens is really the same as 6 tens and 2 hundreds. So just by positioning these numbers in this way, we automatically are making some kind of elementary conversion at the level of each row. So now we have columns that we can be summing. 7 gives us 7. 2 plus 6 is 8. It's the total number of tens in this configuration. And here this 2 gives us a 2. That's the total number of hundreds. So we get 287. The other example, 6, 22, 30. Okay. We write down the 30. So that's the ones column. That's the tens column. Then the 22 is appearing here in the second row, offset by 1s, like a little staircase going down. And the 6 is appearing, again, offset by 1 down there. How far over these numbers extend depends on how big they are. They could extend quite a lot over, but their rightmost endpoints are along this staircase, in the ones position, and in the tens position, and in the hundreds position. Okay, so let me explain again why that is. So this 30 represents 0 ones and 3 tens. This 22 is the total number of tens, total number of $10 bills. If in doubt, convert to money, okay? 22 $10 bills. We've put it here representing the fact that it can be thought of as 2 $10 bills and 2 $100 bills. So just placing it here already kind of makes a conversion for us. And the 6 here is 6 hundreds, so it goes in the hundreds column. That's $600 bills. And now 0, 3 plus 2 is 5, 2 plus 6 is 8. And there we read off the answer, 850. So these are simple examples of cascading. So here's a little bit more involved example. We're trying to convert this open number, 47, 214, 6, 135, into a closed number, or Hindu-Arabic number. So this is the number of ones, number of tens, number of hundreds, number of thousands. This is potentially the number that we get by doing some other sum. Okay, so we have some big sum. We've added up ones, tens, hundreds, and thousands, and these are the numbers we've got. So now we have to convert this. So the 135, the ones, we write down there. That establishes the ones column, the tens column, the hundreds column. Then the 6. 6 represents number of tens. So we put it in this position, aligned with the 3 here. That's the tens position, or tens column. The 214, that's the total number of hundreds. Okay, so that starts over here in the hundreds column and then proceeds left. 214, that 4 is in the hundreds column. The 1 is actually in the thousands column. The 2 is actually in the 10,000s column. Okay, what about 47? Well, again, the staircase just cascading down. Thousands column, that's where we put the 7. So the 4 will also be in the 10,000s column. So again, we can think in terms of money. Think about converting all of these quantities into money. Here's 135 $1 bills, which has been converted into $1, $10, and $100. Here's 6 $10 bills, which are just left by themselves. Here's 214 $100 bills, which have been converted into $400 bills, $1,000 bill, and 2 $10,000 bills. It's another way of thinking about what we're doing. And 47, that's thousands, that's converted into $7,000 bills and 4 $10,000 bills. So we're really conscious of the place value here, right? The position that we're in is very important. And we want the students to have some real physical sense of converting units of one to another. They should know that 10 hundreds is 1,000. That should be automatic. That 10 tens is 100. That 10 thousands is a single 10,000. Okay, now that we have everything lined up, we can just do the addition. 5, 3 plus 6 is 9, 1 plus 4 is 5, 1 plus 7 is 8, 2 plus 4 is 6. So altogether we get 5 ones, 9 tens, 5 hundreds, 8 thousands, and 6 10,000s. And so that's our answer, 68,595. And notice that I'm going to resist the temptation of putting commas in here, okay? Because if I put commas in there, then it's very possible that we're going to get confused between that number and a different open number which looks the same. So note that the rightmost digits in each of these digits appearing in the open number, digits in quotes, are forming a staircase pattern. That's a kind of cascading aspect. Now, the examples that I've shown you up till now are a little bit simple. There's some additional complication that can arise, which means that we have to iterate the process sometimes. Okay, and that's because when we're at the stage of adding the cascading array that we've set up, there's additions involved, and it might very well be that we get numbers that are bigger than 9. So again, we have to work in an open number framework. So we need to be prepared for intermediate open numbers also, so that we don't just go from an open number to a closed number, but we may have to go from an open number to a simpler open number, perhaps to a simpler yet open number, and then to a closed number. So let me illustrate that here. So suppose that at the end of some rather long addition, we get the open number 3, 712, 84, 197. Ones, tens, hundreds, thousands. Okay, we write our cascading pattern like this. Rightmost digits going down sequentially. 197, so that establishes the ones column. Here's the tens column. There's an 84 sitting there. The hundreds column with a 2 out of 712 sitting there. And the thousands column with a 3. Okay, so now we have to add up these things. So 7, that gives us 7. But here we have 9 plus 4, that's 13. So, to be consistent, we should put a 13 there and put a comma. Okay, that's still the tens column. That's still how many $10 bills there are. How many $100 bills are there? There's 1 plus 8, which is 9, plus 2 is 11. Comma. $1,000 bills, 4 of them. $10,000 bills, 7 of them. So, strictly speaking now, we should do the same kind of thing to this, but it's a little bit easier because the numbers are smaller. So let me go over here and do that. So I'll write down the 7 here. Okay, that's establishing the ones column. And here then are the number of tens. And then the number of hundreds. And then the number of thousands. And then the number of 10,000s. Okay, so again, we have a staircase pattern going here. Ones, tens, hundreds, thousands, and 10,000s. For a total number of ones is 7. Number of tens is 3. Number of hundreds is 2. Number of thousands is 5. Number of 10,000s is 7. So altogether we get 75,237, and we avoid the temptation of putting a comma in there. Now admittedly, to get this kind of sum from summing numbers, you probably have to have quite a big sum to do that, okay? So this is not going to happen that often, especially sort of at the elementary school level. But I just want conceptually for you to appreciate that actually addition, even of just a simple column of natural numbers, is a little bit subtle, okay? Especially having to do with the carries. And that's often obscured a little bit in the usual format because we usually restrict ourselves to sums involving, not so many numbers. But if you actually had to sum a column of 300 different numbers, then the problem of carryings and where to put the carryings would become more obvious to you. And the advantages of doing it this way, very systematically, where everything is on the page and not floating around, would become much clearer. But the advantages are going to be even much more strongly apparent when we go to multiplication, where this whole point of view, this whole orientation is going to give us a solid preparation for doing multiplication in a much better way. In our next video, I want to reinforce all of this, okay, by actually playing around a little bit with some Monopoly money. I hope you'll join me for that. I'm J Wildberger. Thanks for listening.